So what I want to do today is talk a little bit about the value of basic research, why we do it, and what we do. And I'm doing that in part because this is the 20th anniversary of Microsoft Research. So it was in September of 1991 that I came to Microsoft to start Microsoft Research. And that's important in a way because it represents a significant commitment over a very, very long period of time. Now, interestingly enough, the decision to start Microsoft Research was something that was made very consciously by the board of directors at Microsoft. So there was a board of directors meeting in 1990. There was a memo written by a man named Nathan Myhrvold to the board. And Nathan described what he thought was the importance and value of Microsoft making an investment in long-term basic research. And the reason that was sort of unusual was that in 1990, Microsoft was a very small company. There were only a few thousand employees. The company was just about to cross over $1 billion in sales. And while that may seem like a lot, it's very small. It's a very small company to be making the kind of decision to invest in long-term basic research. And in fact, very few companies have historically made that kind of commitment that early in their life. Now, from the beginning, I came to Microsoft in 1991, and from the beginning, I've always had a single mission for Microsoft Research. First and foremost, that mission has been to expand the state of the art in the areas that we do basic research. Now, it's interesting because that part of our mission statement says nothing about Microsoft. What it says is that if we choose to do research in an area, we want to do the best job we can. We want to move the state of the art forward in that particular area. So that's the most important thing. Because if we don't do that, if we're not really at the state of the art, then I would argue we're really not going to be that valuable to a company like Microsoft, or to anyone else, really, for that matter. Now, the second part of our mission statement does have the word Microsoft in it. We wanted to make sure that when we had good ideas, when the technology that we were creating made sense and looked like it was going to be valuable, we wanted to work as hard as possible to move those ideas into use, into products, to have an impact on the world with those ideas. And so that's really the second part. Ultimately, both of those things are really about the future. It's about making sure not just that Microsoft has a future, but that the field of computer science has a future, that we're continuing to innovate and we're continuing to change. And while that may seem strange to you because you've been living in a world where computer science has been rapidly changing the world, think about all the older technologies, the older ways of doing things that in some sense stopped making those kinds of dramatic changes and became less valuable in the world. So we want to make sure that computer science continues to have the kind of impact. Now I said, we started Microsoft Research in 1991. Nominally I'm the first employee. We start the history of the organization from September 1st, which is when I showed up. Today, Microsoft Research has grown to be one of the largest basic research organizations in computer science in the world. We have over 850 PhD researchers working in 6 major research labs. And in addition, we have a number of what we call advanced technology labs and centers around the world where we do advanced development and collaboration with other organizations. Now, to put that in perspective, a typical university, let's say Brown University in the United States, actually has fewer than 850 PhDs. So we have, it's really, Microsoft Research in some sense, we have the scope and the size in terms of our PhD base that you might ordinarily associate with a university in terms of the size. Here you see some of the labs that we have. Our main facilities in Redmond, Washington. We have about 320 or so researchers there. But our second largest research lab is in Beijing. Our third largest one is in Cambridge, England. We also have a large group here in Bangalore, in India, in Silicon Valley, in the United States, in Cambridge, Massachusetts, and the Boston area. So Microsoft Research has now grown to really be a worldwide enterprise. And as I mentioned, our advanced technology labs are also around the world. We have groups in Egypt, we have groups in Israel, we have groups in Germany, we have a joint research lab with INRIA in Paris. So again, we've really grown and expanded significantly as time has gone on. Now I mentioned that one of our key goals is moving the state-of-the-art forward. I mean, one way to measure that is really in the contributions we've been making to the field of computer science. And today, Microsoft Research is the #1 publisher of basic research in the field of computer science. So we've grown to be, from a very small organization 20 years ago to the point now where today we generate more basic research in the field of computer science than any other single organization. Now, I also talked about the fact that Microsoft Research, one of our key goals was when we had great ideas, we wanted to get those ideas into product. We wanted to make a difference. We wanted to change the world with what we were doing. And that's also been very successful for us. There is no product from Microsoft that does not either include technology from Microsoft Research or was built using technology coming out of Microsoft Research. So the impact of Microsoft Research on Microsoft itself has been tremendous. And you see that in all the products. And I'll talk more about that as we go along. Now you could argue, why should a company like Microsoft, make investments in basic research? And in fact, the reality is very few companies today in the field of computer science do make that kind of investment in long-term basic research. It's much more typical that companies will invest in advanced development, they'll invest in product explorations, they may hire PhDs, but typically companies in the technology field, for the most part, have not chosen to make those kinds of long-term basic research investments, the kinds of research that you might do within a university environment. So why does Microsoft do it? What do we get out of that? Well, you could make an argument that there are a variety of things. I mean, when people say, why should you do a basic research lab? They're going to make these kinds of arguments that I've got up on the slide. I mean, one thing they'll say is, hey, you should do this because you're going to generate a lot of intellectual property, right? You're going to create a lot of technology, and that's going to have value. And I would say, yes, that's actually true. We do generate a lot of technology. We do create a lot of intellectual property. I mean, Microsoft Research produces about 25% of all of Microsoft's patents. And in fact, our patent portfolio has been seen by the IEEE and others as being the strongest in the technology field. And so, yes, that's valuable. And of course, we generate a lot of technology that goes into our products, and that's valuable. But while that's a value, I mean, while it's a good thing, I would argue that that's not the reason we should make investments in basic research. It's simply a byproduct of the fact that we have. You could say, hey, you hire PhDs, and PhDs solve problems. And in fact, we're really good at solving problems. I personally love solving problems. If you come to me with a problem, a technology problem, I love working on it. I love finding the solution and writing the code and sort of developing the solution to whatever it is you're trying to do. That's great, and we love doing that. We're well trained to do it, and we do it. And that's a value. But again, I would argue that's not the reason to build a basic research organization within a company, and it's not the reason why governments should invest in basic research or universities should do basic research. But it's an outcome of having made those investments. You could say, hey, you're an early warning system. You guys are at the state of the art. You're always hearing things. You know what's going on. Maybe you can tell us something about the future. Well, we're not exactly prognosticators, but we can often give insights to the corporation and insights to our product teams about what is in the lab, what's happening, what are the possibilities. And that's certainly of value as well. But again, it's not, I think, the reason why you make these investments ultimately. I think the core reason why a company like Microsoft invests in basic research, why governments should invest in basic research, why you as students should consider going into a research career is really, in some sense, for survival. It's for agility. It's for making sure that should something happen, should the world change in some fashion, should there be some catastrophe, that we will have the intellectual capacity to change and to be agile. So if you go back to the writings of Vannevar Bush, who helped to create the National Science Foundation in the United States, and in some sense was one of the originators of the ideas that became the modern U.S. research infrastructure, he basically made this argument as well. He said that, we want to invest as a country in basic research because, if there is another war, and remember, he was writing this right after World War II, if there's another war, if there's a famine, if there's a disease, we want to make sure that we have the people and the ideas that will allow us as a society to survive and to persevere in the face of change. And I think the same arguments are true for a company like Microsoft. We want to make sure that should there be a new technology or a new competitor or a change in the business climate, we want to make sure that we as a company have the people and the ideas and the treasure chest of intellectual property and technology that allows us to change, that allows us to adapt, and allows us to survive in what is otherwise a very difficult business environment. If you go back to the early 1990s, when Microsoft made the decision to start a basic research group, and you look at the companies that were Microsoft's peers at that time, the comparable companies, they're basically all gone. They did not choose to make investments in basic research. Ultimately, most of them did not change fast enough, and they were not ultimately able to survive. So I think one of the real values of Microsoft Research to Microsoft has literally been the survival of the company and the fact that we've been able to prosper and grow for so many years. So here's a very, very specific example, and I apologize for the fact that it may be hard for you to see it from the back of the audience. But I just wanted to lay out an instance in time in history where having a fundamental basic research group at Microsoft had a huge impact on the survival and success of the company. So going back to 1992, Microsoft Research had created a technology. It was very early days for the organization. But some of our researchers came up with an idea that they wanted, they came up with a way of taking 32-bit programs, so 32-bit code, and drastically reducing what's called the working set size of those programs. Basically, we came up with a way of reducing by about half the amount of memory that was required for that program to execute properly in a computer. Now, that was interesting. We thought it was really fun. I mean, we thought this was an incredible result. We talked with our product teams. I sat through those meetings personally. We presented our work. They were very appreciative. But pretty much universally, they would tell us after the meeting, he said, well, this is really great. We love this idea, these technologies. You guys are just really, really smart, right? We like you guys. But we don't have 32-bit code. Remember, this is in 1992. In 1992, there was, the predominant hardware architectures were 16-bit. So they had 16-bit code. And they said, but you're really smart. I'm sure you'll, eventually come up with some idea we can really use. Go back to work, right? So they really were basically telling us, we'd solve a problem that they didn't have. Well, fast forward to 1995. Now, by 1995, the predominant architectures that were coming out during that period were in fact 32-bit, and Microsoft was in the transition point. We were developing both 32-bit versions of our Windows operating system and 32-bit versions of our Office products. Now, our product teams had always assumed that the size of computer memories would continue to grow pretty much on an exponential curve. So they assumed that the transition from 16-bit to 32-bit would also be accompanied by an equivalent increase in the amount of memory available, so the fact that the instructions were now taking up twice as much space wouldn't be a problem. But if you look at the graph I have there, and you look around 1995, this is a graph of the prices for computer memory. What you see is that right around that period, the period right around 1995, in fact, DRAM prices, didn't actually drop. In fact, they actually went up a bit. And so the size of memories that people were buying for their computers back then, which, by the way, was about 4 or 8 megabytes, not gigabytes, right? There's very small amounts of memory back in 1995. That what was happening was that people really weren't seeing an increase in the amount of memory that they had available on their computers. So our product teams had a really difficult problem. They had created new products, Windows 95 and Office 95, that were 32-bit, but those products took up twice as much memory in terms of their code as their previous products did. But the computers hadn't grown in size in terms of their memory. Luckily, we had continued to work on a technology that we started back in 1992. We had it available for them. It basically got them back that factor of 2 that they had lost by going from 16 to 32. And so Windows 95 and Office 95 were able to be shipped and run in the same amount of memory that the 16-bit versions of Windows and Office had run in. They became incredible successes in the marketplace. And from a perspective of the company, that technology that we developed and that we created when nobody wanted it, suddenly had allowed us to ship products that generated hundreds of millions of dollars of new revenue for the company at a time when that, hundreds of millions of dollars back in those days for the size company Microsoft was a big deal. But more important than the amount of money that we were able to get because we were able to simultaneously ship those products when we had them ready back in 1995, it had a very important strategic impact. Because our competitors, Lotus and WordPerfect, did not have that technology. They were not able to get their software to run well in the amount of memory that was available in those days. And so this gave us, as a company, almost a year's advantage in the marketplace, where we were able to ship our 32-bit products, and they really weren't. I mean, they didn't really have the ability to ship 32-bit products that worked well. And that had a huge strategic impact and really helped to cement Microsoft's success as the transition occurred between 16 and 32-bit software. So there's an example where fundamental basic research, really looking at problems that no one had asked us to look at and they didn't even want the answer to, in just a few years, were critical to the survival of the company and to its success. Now, I'm going to use another example that's way more recent, which is Microsoft Kinect. So when this was first announced, it was called Project Natal. And this is, again, an example of having the right people and the right technology when the company needed it. So going back right around 2 years before the product actually shipped, the Xbox group came to me in my office and basically asked, can you help us? We have this idea about doing, real-time, 3D tracking of people and using that to control our games. And we have these cameras that we've been working with that give us an ability to track things in 3 dimensions. But they're not reliable. I mean, the technology is not reliable enough to really use. And so can you help us? Right? Well, luckily, we had, both in our research labs in Cambridge, England, in Redmond, and in Beijing, some of the top computer vision people in the world that were able to work with them to help solve those key problems using machine learning, using techniques that they had developed and they could now apply to the product ideas that the Xbox team had. So what they wound up with is something that kind of looks like this. I know they're giving away some Xboxes here, so you'll have a chance to do this yourself. But what's interesting about this is that they built a product where you didn't have to have a controller. It was sensing you in real time. It was seeing your body. It was seeing your body motions and movements and translating them into action on the display and action in the game. So that was the thing they wanted to build. That was the thing that we did eventually ship. And it was incredibly successful. In the first year the Xbox was released, in the first Christmas season, over a 60-day period, we sold 10 million Xbox Kinects. To put that in perspective, that made Xbox Kinect the fastest-selling consumer electronics product in the history of the United States. Just this last Christmas, now it's over a year since it was originally released, on the day after Thanksgiving in the United States, Microsoft sold 750,000 Xbox Kinects and almost 1 million Xboxes in one day. So the product's had just a tremendous success and appeals to people in a significant way. Now I'm going to show you a little video clip, and there is audio on this one that I'd like to have come up, that talks a bit about the research effort that went into Xbox Kinect.
Until now, if you wanted to measure the movements of parts of somebody's body, you'd need some kind of a device like a remote or a marker. But now, with Natal, the body itself is the input device.
Project Natal allows you to control your character, your games, your entertainment experiences through movements of your body.
This is the dream of every researcher, taking their blue skies research and seeing it being shipped to millions of people.
Folks in my group come from all walks of life, from musicians to artists to algorithmic developers to researchers to product people. The way that we incubate is essentially to actually embrace all of these different work styles.
The first time that you discover something new that you love. That's what the first moment was like when I walked up to the sensor, gestured, and saw that come to life on the screen.
We knew we had something when we took the first demos that were using the skeletal tracking technology, and we actually had people using every part of their body. Not only were they smiling, but they said, hey, I was actually there.
One of the brilliant things is that the 3D camera, for the first time, is going to be available. That gives you the three-dimensional information about the distance to every point on the body, but it doesn't actually give you an interpretation of where the limbs are, what the angles of the joints are. So for that, we need to build software.
What Natal does is it evaluates effectively trillions of body configurations every frame. We've made it do that 30 times a second.
The person playing with Project Natal doesn't need to change their actions or change their behaviors to fit the technology. Natal technology actually changed itself to fit the way that the player plays.
I think this is one of the most successful applications of machine learning and computer vision that's ever been deployed. We should absolutely expect the unexpected.
It's 50% hardware, 50% software. The beauty is that we have the ability to tie those together in a magical experience.
From the technology side, our goal is just to make that absolutely seamless. You act, it understands.
The idea of using your body as a controller, the idea of controlling things with your voice, the idea of connecting with players like we'd never connected before. Suddenly, that white sheet of paper in front of me was filled with ideas.
The opportunities to delight consumers, to make our art form more accessible to a broader audience. We've given you a ticket to the coolest party and given you a megaphone to shout out and to interact with the people around you.
So I knew that, so when I knew this product was going to be successful, we were on the beta in my home, was when we put this in front of my two young boys. One of them at the time was, I think at the time they were 9 and 10 originally when they first saw the thing. And what was exciting was not only would they play the game, and they had a huge amount of fun doing that, but I realized they were having just as much fun celebrating afterwards because they could jump up and down and celebrate, and their character was doing exactly the same thing. So it wasn't just the playing the game that was fun, it was the winning and the celebrating that was fun. And you could see that they had made the connection between themselves and the character in the game and the character on the screen. And they'd link those two together in their mind. And so I knew we really had a tremendous success, and of course it turned out to be that way when we sold the product. So again, this is an example of long-term basic research, some of which started in the 1990s in computer vision. Not being done for any specific reason. In fact, we started our computer vision group at Microsoft Research before there was any part of Microsoft that could conceivably have used the technology. But when the time was right, when the opportunity presented itself, we were able to use that technology, and more importantly, we were able to bring to bear the people, our researchers, on the problem in such a way as to create something that, frankly, nobody saw coming. I mean, not even in the research community. I think one of the things that was really exciting about Kinect, from my perspective, was not just the impact on Microsoft. I mean, obviously, it's generated billions of dollars in revenues for us. But to see the impact on the research community as they began to use Kinect to do new research, both in user interfaces and in other areas of technology. So in some sense, the product we created was not just stimulating business for the company, but it was stimulating new ideas and stimulating new research. I think that was pretty exciting. Now we're not really stopping there. We're continuing to look at new things that we could be doing, and somehow they've disconnected my clicker. Let's see if I can make this happen the old-fashioned way. Oh, no. There's no power. That's what's wrong. Okay. Is it going to come back now? There we go. So I just want to give you a taste of some of the newer work we're doing, where we're continuing to experiment with the idea of what can you do if you have a real-time three-dimensional vision and how you can generate it. Here's an example where we're using Kinect cameras to create, and a half-silvered mirror, to create a virtual environment. So the things that he's manipulating there are virtual. The container is real, the ball is virtual, and he can move them back and forth and pick up objects and put them down. So again, we're trying to explore the notion of really creating a virtual environment that you can interact with as naturally as you would interact with the physical world. And we've just released an SDK for Windows for the Xbox. For Windows, so the Kinect for Windows SDK. And in February, we'll start selling a peripheral for Windows that will use the Kinect technology. I'll just go on from there, if I can.
OmniTouch is a wearable system that enables
here's another
graphical,
example, and you can turn the sound off. I don't need the sound of this. See if I can get it back. you go to the next slide there.
Is a wearable system that enables...
Here's just another example where, in this case, we're using a Kinect camera that's actually sitting on somebody's shoulder and a small projector, and allowing you to create an environment, that is directly in front of you, which, you could use your body, you could use pieces of paper. Here's just an example. And again, part of what I'm trying to do here is just point out that the kind of real-time 3D computer vision technology that's embodied in Kinect and in the technologies we've created around Kinect can be applied in many different ways, and really opens up the possibility of doing many new things that we weren't able to do before. We're already using Kinect, for example, in operating rooms, where it's being used as a way for surgeons to interact with their computer system. So anyway, just wanted to show you some of those things and get you a sense of what was going on there. Can we move on? All right, so let me just summarize. 20 years ago, Microsoft, which was a very small company, made an important decision to invest in long-term basic research. That investment for us as a company has paid off incredibly, not just in the survival of Microsoft, but in the creation of technologies that are really helping to drive the field of computer science itself. We think it's important to make those kinds of investments. One of the reasons, frankly, that we do this conference each year is to help to generate interest, because we need you. We need students to make decisions to go into basic research in computer science, to become the people that will create the technologies that will continue to drive that future, and for the betterment of society and for the survival of our society. Thank you.